Hi everyone, so today we are going to look at solving rational equations. So here are the couple steps that you need to remember on how to solve a rational equation. So we first want to list any restricted values based on the denominator of each term. So when we think about that, we have to kind of think about what can't be a solution. So I'm looking for numbers that would make my denominator 0. Then I'm going to rewrite the problem with the LCD. I'm going to simplify and solve. And then I'm going to check for extraneous solutions and exclude them from my final answer. So again, these extraneous solutions are based off of those restricted values, like what makes the denominator 0. So let's look at this example. So in this example, we want to find the restricted value. So I'm looking at my denominators and I'm looking to see what numbers would make my denominator 0. So when I put in 0 for x, I'm going to get 0 in the denominators. So that would actually overall can't be true. It can't be a solution because I can't divide by 0. So my restricted value is going to be 0. I'm going to find my LCD, which I got to take something in common, which are my x's, and then one of everything, which would have been the 2. So my LCD, my least common denominator, is going to be 2x. The next step is I'm going to rewrite the problem with that LCD. So I'm looking at 2x and I'm looking at each fraction and I'm looking to see what do I have to multiply those by in order to get that denominator to match the LCD. So that first fraction is I got to multiply by 2, the second fraction is multiplied by x, and the third fraction is to multiply by 2. So then I'm going to simplify and solve. So I'm going to go ahead and multiply everything together. I'm going to say I got 6 over 2x, and then 1x over 2x, and then 24 over 2x. So what I notice is that now all my denominators are going to be 2x. So if I want to solve now, I'm actually going to ignore the denominators. They're all the same, right? So I'm going to just focus on solving my numerator. So I've got 6 plus 1x equals 24. And when I'm solving for x, I'm going to subtract 6 from both sides. And I'm going to get x is equal to 18. Now your final step is to check for extraneous solutions. So these are again related to your restricted values. So what are the answers that make that denominator 0? So my restricted value was 0, so I know I can't have 0 as an answer, but my answer was 18, so I'm actually good. So my final answer, my final solution is going to be x is equal to 18. In my second example, I'm going to again find my restricted value. I want to kind of consider that 7 is actually 7 over 1. So my restricted value is x cannot be 2. So if I have 2 as a value and I plug it in for x in either of those denominators, I'm going to get 0, which I can't have. That LCD I'm going to have is actually x minus 2, right? I'm taking whatever was in common, one of each. Now you could put a 1 in the front, doesn't matter, but LCD is going to be x minus 2. So now I'm going to rewrite that problem with the LCD, which means I have to actually manipulate that second fraction and multiply it by x minus 2. I'm going to simplify and solve. So then I would get all my denominators to be x minus 2, and I'm going to distribute that 7 and get 7x minus 14. Now in order to solve, I'm going to ignore the denominators and then focus again on my numerators. We're going to solve for x here, so subtract 7x, simplify the right-hand side, divide by negative 2, which gets x is equal to 2. But remember, my final step is to check for extraneous solutions. So my restricted value telling me that x can't be 2, but I got an answer of 2. So that won't work, so I'm actually going to have no solution. Okay, for this question, again, notice that you got that 3, so it's like 3 over 1. With your restricted value, what will actually be helpful is if I factor that x squared minus 1, I'm going to get x plus 1 and x minus 1. Helps you to kind of break down those factors, and you can see that you do have an x plus 1 and an x minus 1 and that will help you as well as with your LCD. So restricted values, I can't have +1 and I can't have -1. Those would both make the denominators equal to 0. My LCD, again, because I was able to factor, I saw that the x plus 1 was in common, and then I have that x minus 1 in the second fraction. So my LCD is the x plus 1 and x minus 1. Now again, when you're trying to rewrite your problem with the LCD, see what's missing. So I have to multiply the first and the third fractions here. When I simplify and solve, for the first fraction, you're actually going to FOIL or double distribute. Use your box method if you'd like to multiply x minus 1 and 4x plus 1. You're going to get 4x squared minus 3x minus 1. 12 stays the same. Now that third fraction is actually the x plus 1, x minus 1 came from x squared minus 1. So when I take that 3 and multiply by x squared minus 1, you get the 3x squared minus 3. Again, if you didn't see that little shortcut there, you can again use your box, distribute, and multiply. Again, remember to solve, we're going to ignore those denominators and focus just on the numerators here. Now, something that you should see is that because I have an x squared and I have an x, you should think back to when you learned about quadratics. Now, remember, if I want to solve a quadratic, I actually have to have my equation equal to 0. So I'm going to move that 3x squared, 12, and that -3 to the other side to get my equation equal to 0. Now you have a nice quadratic equal to 0, so now you ask yourself, well, if I want to solve this, I'm going to try to factor first. I could use my box, and I'm going to get x minus 5 and x plus 2. Now, when I want to use my zero product property and then set each factor equal to 0, I get two answers now. I get 5 and -2. Now go back. Check for extraneous solutions. Your restricted values were -1 and +1, and that doesn't occur actually in my solutions there, so I'm good. I'm going to have two answers of x is equal to +5 and x is equal to -2. Okay, now sometimes what you might see is that you get a rational equation that contains a single expression on both sides. So there are actually two ways that you can solve this equation. You can rewrite with the common denominator like we did in the last few examples, or you could actually cross multiply to solve for x. Again, you have to check for extraneous solutions anyways, so let's show you both ways on how to do it. So here's an example where you have a single expression on both sides. Now I'm going to show you the same way as we were doing in the last few examples. So let's find my restricted values. Factor that x squared minus x first. So you can actually see that you have an x minus 1 and an x. So that's where your two restricted values are going to be coming in. That 0 is coming from the x that's in the front, and then the 1 is coming from the x minus 1. I can't get 1 in there because that'll get me 0. Because I was able to factor, you can actually see your LCD a little bit easier. So I do recommend factoring so that x and then the x minus 1 that's in common, those are both going to be part of your LCD. You're going to rewrite your problem and multiply the second fraction by x. So I'm just going to change that second fraction. So when I simplify and solve, I get 1x on the top and x minus 1x on the bottom. When I solve, again, I'm going to ignore my denominator, so I get 2 is equal to 1x, so x is equal to 2. My restricted values were 0 and 1, so when I check for extraneous solutions, I'm actually good. I don't have to worry about anything. So that's solving using a common denominator like we did in the last few examples. You can actually also solve this question using cross multiplication. So when you do that, right, I can cross multiply kind of like a little butterfly that you might have learned when you were actually solving proportions. So I could cross multiply, again, solve. In this case, I'm going to actually notice that I have a quadratic. I can factor that quadratic. You will get two answers, but what you should notice is that the x minus 1, hey, that was a restricted value, so that actually won't be included in your answer. So notice that the answer is still, again, x is equal to 2, so both ways are going to get you the same answer. Now, it's not like one's going to be easier than the other. It really depends on the equation. So whichever way you're more comfortable with is fine to use. Okay, so now here are some things for you to remember. Always make sure you are checking for extraneous solutions after you solve your problem. And then remember, you can only cross multiply, like a proportion, if there's a single expression on both sides. So it does have to look like a proportion. You can't use the cross multiplication for the previous examples that we had at the beginning. Now I hope this video helped you solve rational equations. Thanks for watching and have a great day.